Alright, so today we're going to talk about midpoint formula. And so today we're going to do a little bit differently. I'm going to actually give you the formula, and then we're going to do some examples, then come back to why we get this formula. Is that okay? So let me give it to you. I bet a lot of you already know. Okay, so hold on, let me set this up. So here we go. It's a theorem, the midpoint formula. The midpoint of the segment that joins points x of 1, y sub 1, and x of 2, y sub 2 is the point. Anybody remember from, I don't know, maybe, is it intro or something? Okay. Who remembers what the midpoint formula for 2 points, x sub 1, y sub 1, x sub 2, y sub 2 is? No one remembers? Okay. No one remembers, really? What's the formula? Oh, you're all copying it down? Okay. Okay, so I'll give you time then. Copy it down and think about, see if you remember what it was. Midpoint formula, the point right in the middle of these 2 points. Anybody? I'll just tell you. It turns out it's just the average of the x's, comma, the average of the y's. So Hannah, what do you think it is? Exactly. It's x sub 1 plus x sub 2 over 2. That's the average of the x's, comma, y sub 1 plus y sub 2 over 2. Okay, that's it. So write that down. I'll wait. Okay. You guys remember this? No? If you don't, that's okay. We're giving it to you right now. Okay, so that's the formula. Okay, if you have 2 points, you want to find the point right in the middle of it, that's the formula you use. Okay, it'll get you the midpoint every time. Okay, and it kind of makes sense, right? Why it comes out to be this way. You want to find a point right in the middle, you take the average of the x's and take the average of the y's. Right? Does that make sense? Alright, let's do some examples. Here. It says find the midpoint of these 2 points. Negative 11.3 and 8, negative 7. Well, you have the formula. Right? Go ahead and find the midpoint. Go ahead, I'll wait. Give everybody a try. Alright, Emily, what did you guys come up with?
Negative 3 over 2 and negative 2.
Negative 3 over 2, comma 2. How many people agree with Emily? This group? Yeah. Okay. Good. Yeah, when you find the average of the x's, you get negative 3 over 2. When you find the average of the y's, you get negative 2. So that's correct. Okay. So negative 3 over 2, comma negative 2 is your midpoint. Any question? Don't make silly mistakes, guys. You know. Okay, then you're not going to get the right answer. All right. May I move on to the next example? Yes? Okay, here we go. Okay, here we go. Example 2. It says you got a point A 2, 1 and B at A5. So you have these points and show that P is on the perpendicular bisector of the segment AB. So given points A, B, and then they want you to show that point P is on the perpendicular bisector of the segment AB. Okay. So how would you do this? What does this have to do with midpoint? Right? I mean, are we learning midpoint now? What do they all of a sudden give us this? Anybody see any connection? Go ahead, everybody discuss with your group. I'll wait. How has that got to do with midpoint? All right, so first of all, what does this problem have anything to do with midpoint of a segment? Okay. 2 people see it? That's it? 3, 4, 5, okay. Jason? Yeah, what do you know about a perpendicular bisector to a segment? It goes through the midpoint, okay? So here's a picture, right? You need to find that midpoint, and that's a bisector. But how do you know it's a perpendicular bisector? That's not good enough. Yes. Yeah, you find the slopes, and if you find the slopes, right? What should be true if they're perpendicular? When you multiply them, it should be negative 1, right? So go ahead and find the midpoint. So there's a picture. If you draw it, it's kind of helpful, right? Find the midpoint, then look at their slope, right? Slope of AB to PM. And you see if they are. Not only does it bisect, right? Because if it goes through M, it does bisect. But is it perpendicular, right? Go ahead, everybody try. I'll wait. Everybody try. We'll wait. All right, who's got the midpoint, first of all? How about, let's see. How about somebody around? Leo? 5-3. How many people agree with Leo? Okay, very good. Okay, it is 5-3. Because you just find the average of the x's and find the average of the y's, right? Then we're not done. Okay, so that's the midpoint. We want to know whether or not this PM is perpendicular bisector, right? So it does go to the midpoint. Okay, so what do we do next? What's the slope of then AB? Krista, what did your group come up with? 2 over 3. 2 over 3. How many people agree with that? Okay, good. That's correct. 2/3. And lastly, we need to find the slope of PM. Ethan, what'd you guys come up with?
The slope of PM is 3 negative 2.
3 negative 2, which is negative 2/3, right? I mean negative 3/2, same thing. So do we get negative 1 when we multiply them? Yeah. So that's why, right? Since the product of the two slope is negative 1, they are perpendicular. Okay. Does that make sense? Easy enough? Does anybody see another way of doing the same thing? Do you guys remember anything about a point that's on a perpendicular bisector of a segment? Yes. It's the equidistance from to the endpoints, right? Do you guys remember that? If P is right on a perpendicular bisector of AB, we need to show then PA is equal to what? PB. Could we do that too? What would you use to figure out the distance? You use the distance formula, right? And if you did, you would have gotten that their distance is rad 26. Okay, so you could have done it this way. Doesn't matter, right? So there are two methods. There are two methods of looking at, right? How to show that P is on the perpendicular bisector of AB. Any question? Which method do you guys like better?
First one.
You like the first one? Yeah. Second one, you kind of have to, but it's the same thing. Okay. Does that make sense? Are we good? All right. Good. Okay. So now that we've done some examples, let's think about then how do we get this midpoint formula? Okay. So we're kind of working backwards. So let's think about y. The midpoint formula is the average of the x's and average of the y's. And we'll do some more examples afterwards. But first of all, when you have a horizontal line, though, it's really easy to find the midpoint, right, of 2 points on a horizontal line. Would you not agree? Like, for example, if I have a number line like this, how would you find, like, on a number line, how would you find the midpoint of AB? Yes? Yeah, you add A and B, right? And you divide it by 2. Wouldn't they give you the midpoint? Okay. Now, so vertical line is pretty easy. I mean, horizontal line. Same thing works for vertical line too, would it not? So this is what it's showing you. By the way, if you have it on a x and y axis like this, how would you find the midpoint of this horizontal line CE? Well, what do you know about a horizontal line? What's always same for both of these? All 3 points. In terms of order pairs. If they're on a horizontal line, y is always same. So you don't have to even worry about y, right? Because D would have the same y coordinate as well. C and E. Because they're so all you have to do is look at their x coordinates and find their average. Because look, the y has to be same. So what is negative 1 plus 5 over 2? That's 2. Does that make sense? Same thing will work for a vertical line, right? So for example, if I have F, G, H, what do you know about all these 3 points that are all vertical? They all have the same x coordinates, so all you have to do is look at their y coordinate and find the average, right? So notice they all have the same x coordinate, negative 2. And what is 1 plus negative 3 divided by 2? Negative 1. Do you see how we get that? And of course, so for vertical line and horizontal line, that's pretty straightforward. But what about for a line that is not vertical nor horizontal, right? That's the important, that's the interesting one. So let's look at that one. So here, it turns out knowing the midpoint of a horizontal line and a vertical line is going to be helpful for us. So here, I have PQ, okay? And do you think those dotted lines are going to be helpful for us to figure this out? Okay, so we got M. So we have a midpoint, right? M. We have a midpoint of M on PQ, right? M is the midpoint of PQ. So if the M is the midpoint, what can you tell me about MT and PR, these two segments? They are parallel, right? Because MT and PR, they're horizontal, right? They're both okay. What about MS and QR? They're also parallel. Okay, and do you see how this point R is x sub 2 comma y sub 1? Why? Because look, PR, they're parallel, right? So since they're parallel, what must they have in common? Same y coordinate, right? What about, because QR, there's a vertical line, right? Since QR is a vertical line, what must they have in common? The x's. That's why it's x sub 2 comma y sub 1. You see how that works out? Okay, so that's good. So if M is the midpoint and MT is parallel to PR, we know something about T. Let me remind you of this theorem. Let's see if you guys remember this. Who remember? Somebody read this for us. How about Jonathan? Can you read this for us?
The line that contains the midpoint of one side of a triangle and is parallel to another side passes through the midpoint of the third side.
What is this saying? This is saying, look, if M is the midpoint of AB, right, and MN is parallel to BC, you guys remember this from chapter 5? Okay, what do you know about N? N is the midpoint of AC. You guys remember this? Right? So, okay, well now I'm showing you, but do you now understand what it's saying? Remember, it's a theorem we actually proved. So if M is the midpoint of one side of the triangle and it is MN is parallel to BC, N is the midpoint of AC. Okay? So if that's true, let's go back to this triangle. Actually a right triangle, isn't it? This is a really right triangle. Anyway, so look, we said M is the midpoint of PQ, right? Because we want to find the actual order pair for M. If M is midpoint of PQ, look at MT. MT is parallel to PR. So what must T be? Midpoint of QR. So those two segments are congruent. Using the same argument, what do you know about MS? Isn't MS parallel to QR? So S is the midpoint of PR and SR. I mean PS and SR, right? Those are congruent, right? So S is the midpoint of PR. Does that make sense? So it makes those two segments congruent. So if that's true, now something interesting happens. If that's true, what is the actual order pair for this T? Notice T is on this vertical line QR. So what must they have in common?
X.
So it's going to be x of 2 comma. What about y's? Remember we were able to figure out the midpoint of the vertical lines, right? Y was what? The average of the y's, right? So y sub 1 plus over 2. Would you not agree? Right? For a vertical line, right? We just have to worry about the y coordinates, right? X is same. What about the horizontal line? What is the order pair for this S? What must be in common? Y. So y sub 1. We know it's going to be y sub 1, right? Because they're horizontal lines. What about the x then? X sub 1. It's the average. X sub 1 plus x sub 2 over 2. Isn't that right? So then what is the order pair for M then? That's the big question. Notice M and S, aren't they vertical lines? What must they have in common? X's. So it's going to be x sub 1 plus x sub 2 comma 2 comma. What about M and T? They're horizontal line. What must they have in common? So it's going to be y sub 1 plus y sub 2 over 2. And does this look familiar? Yeah, that's the theorem. That's how we get the midpoint. So have you noticed all these sort of theorems that we've been proving? We've been kind of using algebra, right? Turns out we're going to be proving yet another method. There's a different way of proving. It's called algebraic proof. That's what we'll be working on. That's why if you notice, like last couple of theorems and stuff like that, we've been using a lot of algebra, right? So that's what we'll be using. Okay. So does that make sense? You see how we get the midpoint there? Okay. All right. So let's do some examples knowing this. Okay. Here we go. Some simple ones. All right. Here's example 3. Kind of going back to what we did a little bit. Okay. So it's kind of a review, right? Let's see if you could do this now. Go ahead, everybody try. Tell me the midpoints of these points. A, 5, negative 2, 5, 8. B, B plus 2 comma 0, and then 3B comma 6. By the way, look at A. 5, negative 2, 5, 8. What kind of line does it make? It's a vertical segment, isn't that right? That's why they have the same axis. So yeah, you could just worry about, but would the midpoint formula still work on this? Yeah, it'll still work. Okay. Yeah, go ahead, everybody. Yeah, go ahead, everybody try. I'll wait. All right, Kenneth, what'd you get for A, please? 5 comma 3, right? Yeah, because you just take their average, right? Look at the x's. You add 5 plus 5 divided by 2. What do you get? 5. You see, it still works. Okay, even if it's a horizontal line or vertical line, right? It doesn't have to be, right? It doesn't have to be the regular. It doesn't have to be non-horizontal or vertical. Okay, B. Jonathan, what'd you get for B?
2b plus 1 comma 3.
Yeah, 2b plus 1 comma 3. Is that right? right? B plus 2 plus 3b, isn't it? Don't you get 4b plus 2? All over 2. You factor out the 2 and then you cancel. Any question? Easy enough? Yes? Okay, that was pretty straightforward. Let's look at example 2. Let's get a little bit more interesting. Okay. It's not that hard. Okay, example 4, it says if M 6, 2 is the midpoint of line segment AB, where the coordinate of A are 8, negative 7. Find the coordinate of B. So this is kind of working backwards, exactly. Go ahead. But it's not that hard. It's like you just use the formula. That's all you have to do. Okay, go ahead. Everybody try. And of course, you could help each other out. Go ahead. Okay, so how do we do this one? How about Young? What did you do? What did your group come up with?
So since 8 plus a number divided by 2 equals 6, and negative 7 plus number divided by 2 equals 2, I just plugged in like the number and then I got 411.
Exactly. So how many people got 411? That's the answer. Very good. Very good. So good. Now what I did was I said let B be x sub 1, y sub 1. I guess I could have called it xy or ab, whatever you want, right? And all you have to do is plug into the midpoint formula, right? You have to get 4 when you find the average of the x's, correct? So thank you. So when I do this, I just simply do 8 plus x sub 1 over 2 should equal to 6. Do you know how to solve that? Yeah, you get 4 when you do. And then you just do negative 7 plus y sub 1 over 2 equals 2. You know how to solve that? You get 11. Easy enough? All right, let's do one last one then. Okay, example 5 turns out is exactly the same as example 2 that we just did. Now see if you could do that with different numbers. Okay, given point A, 5, 2, and B, 3, negative 6, show that P, 0, negative 1, is on the perpendicular bisector of AB. Okay. So it's sort of a review, right? We just did it. Can you do it again? So it's the same exact question as example 2. But do it without looking at the example 2. Remember, there were 2 ways of doing this, right? Go ahead, everybody try. I'll wait. Okay. So let's see. How do we do this? This is the same exact one we did with different numbers. Julie, what did you do first? To see if P is on the perpendicular bisector of AB?
I found the midpoint.
Good. You found the midpoint of AB. What did you get?
I got 4, negative 2.
4, negative 2 is correct. Did you all get, so this is method 1, right?
Yeah.
Finding the midpoint and so forth. Did you all get 4, negative 1 as the midpoint? Okay, then what do we do next? Reagan, what should we do next?
I got the slope of 4, negative 3, and 0, negative 1.
Okay, so you found the slope of MP, right? So what did you get?
Negative 1, 4.
What about the other one? Did you get the slope of AB?
Yeah.
What did you get?
4.
Exactly. So you get 4 for slope of AB, and then you get slope of PM or MP as negative 1, 4. Correct? And am I done, or should I multiply them out and show that it equals to negative 1? Yeah, that's what I should do. Okay, multiply them out. It does equal to negative 1. So therefore, they are perpendicular. So it's on the perpendicular bisector. Are you okay? Because we have shown that that's the M, right? And then M is the midpoint, and then they're perpendicular. All right, did anybody do it the other way? One person? Okay, 2 people? 3, 4. All right, Hannah, what did you do? What's the other way?
I used the distance formula for P and A.
Yeah, you find the distance for PA and PB, right? BP or P. So what did you get? What's your distance?
I got around 34.
Did you guys agree? Rad 34? Josephine and Brandy? Okay, you guys are correct. It is rad 34, both of these, right? So since they are equal distance, and what do we know? Well, since their PA and PB are equal, and then P is on perpendicular bisector of AB. So therefore, P is on the perpendicular bisector of AB. Because of that theorem, remember? Right? If the point is on the perpendicular bisector, it's equidistant from the endpoints. Any question? Can you do something like this for your homework tonight? All right, good.